Hello, everyone. Welcome to the session. Allow me to share my screen. And let's get started. There we go. How is everyone doing? Thank you for taking the time to be here with me today. I know you have options these days. I know there's plenty of events you can go to, so I'm glad you're here in DevDays, and there's plenty of sessions to choose from. So I'm equally happy that you chose mine. Now, I was supposed to do this in person in Lithuania, but due to circumstances, which I understand, we're here virtually, and a lot of the jokes can backfire here. So I usually start all my presentations about Varnish, about caching, with a couple of statements. And I use these to convey my vision on certain aspects, but also to get interaction from you. So since I'm not on an actual stage, we'll see if the chat can offer any way to interact. So I'm going to present 3 facts with you, or 3 opinions rather. And if you feel strongly about it, for it or against it, please let me know. Please scream on the chat. Don't hesitate to use uppercase. So here we go. Statement number 1. Slow websites suck. So that is statement number 1. If you feel strongly about this, do not hesitate to let me know in the chat. Statement number 2 is web performance is an essential part of user experience. And with that, I mean that if your website is slow, people will find a way to go elsewhere. There's tons of competition out there. So make sure that when you are designing your application, your platform, that you ensure that performance is part of the analysis. And a third statement, which may be slightly more controversial, is that a slow website is just as bad as a website that is down. One could argue about that. But either way, if your website is slow or down, you will lose money. You will suffer from reputation damage. And you might even lose a little bit of Google PageRank. So we need to keep that in mind. Now, what a lot of people try to do to mitigate these kinds of aspects is throw servers at the problem. Okay, we have a lack of capacity. Our website is slow. Our website is unavailable. We need to add capacity. I must admit, in the short term, it's a great solution because if there's a fire, you need to do firefighting. But in the long run, the problem is that you add complexity. And we all know distributed systems are hard. The more systems you add, the more servers you add, the more complicated it gets. And also from an economical point of view, it's a bit tougher. And as the famous poet and rapper Notorious B.I.G., aka Biggie, once said, more money, more servers, more problems. So what's the alternative then? How do you tackle these issues? Well, at the other end of the spectrum, you could say, well, we'll identify the slowest parts and try to optimize. And that is the most sensible thing to do. Instead of figuring out ways to compromise and to find alternative solutions to the problem, why don't we look at the root cause and try to optimize? Figure out code to fix, figure out database schemes to fix, maybe figure out ways to optimize your stack. That is a way. But unfortunately, as it goes, after a while, you may hit the limits or the so-called point of diminishing returns. And with that, I mean that you'll invest a lot of developer money, a lot of ops money, a lot of resources. And in the end, the results will not yield in the same way. You may notice that in the beginning, you have lots of gains, but the seconds or milliseconds that you're trying to gain after a while, it just isn't worth all the money. So option A is not a good one, or is a good one in the short term, but in the long run, it isn't. Option B will cost you a lot of money and is no guarantee for success. Is there another solution? And the answer, of course, is yes. And that is, why don't you try caching the output? And I use the analogy of boxes, the metaphor of boxes. Caching is nothing else than storing computed results in boxes for later use. So instead of recomputing all the data, knowing that the output will be exactly the same the next time you present the page, why don't you just store that result and ensure that you don't get that heavy load on your origin system? And that is what this entire presentation hinges on. With that being said, hello, my name is Thijs. Yeah, that's how you pronounce that, Thijs. I'm a Belgian, and I was really excited to travel to Lithuania. That would have been my first, can either call it post-COVID or mid-COVID trip. But I think the organization made an excellent decision of turning it into something virtual, because travel, we're still a bit in limbo. I'm the technical evangelist at Varnish Software. So I love speaking, but due to the pandemic, I'm probably a bit rusty. Do let me know if you give me feedback afterwards. For those of you who don't know, Varnish Software is a company. It's a Scandinavian company with offices worldwide. That is the company behind the very popular Varnish Cache reverse caching proxy system. We also have a commercial product, Varnish Enterprise, that builds on Varnish Cache, adds support services, and a ton of extra features. In terms of numbers, about 4.8 million websites use the technology, both open source and commercial. And if you look at the top 10,000 websites, about 19% uses the technology. So that is kind of nice. I'm also available afterwards. I'm available for you right here. And after the session, there'll be a little bit of Q&A. So I will be available to you. But if you want to reach me afterwards, I'm at Feryn on the various social media. So if you have questions, remarks, want to get into a conversation, that's the place to do it. I'm also the author of Varnish 6 by Example, which is a book that has been out for a month now, I guess. This was my 2020 work, and I'm hoping in the next couple of weeks, the paperback version will be live. In the meanwhile, you can still buy my old book, Getting Started with Varnish Cache, through O'Reilly. That's still available. So let's get down to it. If you don't use a reverse caching proxy, a CDN system like Varnish, there will be a direct interaction pattern between user and server. And that is simple, and that is good, and that has served many use cases. The problem is, as the number of concurrent users increases, the server will suffer, and you will have lots of latency or even downtime. So how does Varnish work, and how do systems that are similar to Varnish work? Well, they act as a reverse caching proxy. So that means they are sitting in front of the server, in between the user and what we call the origin server. And the goal of Varnish is, because it's super powerful, super fast, is to take all these requests in. It acts as we call an origin shield. So the server is called the origin, and Varnish, which sits at what we call the edge, is receiving all the requests and tries to serve responses from cache. However, if it doesn't have the response in cache, it will connect to the server and fetch the content there. The problem you might think Varnish will experience is that if millions or hundreds of thousands or even tens of thousands of users are accessing the same uncached content, the server would be overloaded. But that's not the case. Varnish has this feature called request coalescing. So even though maybe 100,000 users are connecting to Varnish at the same time, getting uncached content, Varnish will send a single request to the server, queue all the rest, and satisfy that entire queue in parallel with a single backend response. So it's truly an origin shield. Now, if you're still confused about this, and this may happen, I always put in the following slides and the following image. It's a trick I usually pull, and it's usually the more old school people in the chat or in the room that get this. So I will ask you again, if you're willing to entertain me with that. Anyone has any idea where this image comes from? So I'll give you about 5 seconds. So if anyone is super hyped about this, please let me know in the next 5 seconds. Otherwise, I will just explain the joke. So 4, 3, 2, 1. This comes from The Bodyguard. This is a 90s movie with, as you can see, Kevin Costner, Whitney Houston. And Kevin Costner plays the role of a bodyguard, protecting Whitney Houston from stocky fans. And that, when in doubt, is exactly what Varnish does. I see someone in the chat, Carolis, movie Bodyguard, indeed, congrats. So in this case, the metaphor is, when in doubt, compare Varnish to the bodyguard. Varnish is Kevin Costner, and your origin, your talented origin application, your popular origin application is Whitney Houston. So when in doubt, think of Kevin and Whitney. There's many types of caches out there. And it often gets confusing to users. I want to mention that the type of cache Varnish is an HTTP cache. It speaks HTTP. This also means that all the conventions from HTTP do apply. So there's a bunch of conventional headers that allow you to control caches, and Varnish respects those as well. I threw a random number on it right here. So there is this expires header. We all know it. I do want to mention it's deprecated, but Varnish still supports it. So if you send a response with that response header, well, as you can see, September 9, 2017, that is very much in the past. So that means don't cache the content. If it would be a date in the future, well, then it would be cacheable. But again, this is deprecated. So let's focus on more interesting headers. I would say the cache control header. It is the bread and butter of caching. So the first example uses statements like public, maxh, and smaxh. Public means both browsers and intermediary caches like Varnish can cache it. Normally, you would be focused on the maxh, which is set to 3,600 seconds. That is an hour. But this is specifically designed for browsers, not necessarily for caches. Caches are supposed to follow the smaxh directive. So in this case, Varnish would cache it for 86,400 seconds, which equals a day, and the browser may choose to cache it for an hour. Now, if there's no smaxh and just the maxh, Varnish will use the maxh value. The other thing that Varnish does is it can also control stale while revalidate. So the next option says stale while revalidate 100. This means if the cache has expired, let's say that 3,600 seconds have expired, normally the next visitor would have to wait until the content comes in due to revalidation. But stale while revalidate says in this case that even if the time to live has expired, for the next 100 seconds, you can serve stale content while Varnish is asynchronously getting the new version. That way, new users aren't penalized for getting stale content. You can also decide not to cache by using private or no cache or no store, or you can even choose to use maxh or smaxh with a 0 value. And there's also another set of headers called surrogate headers, and the surrogate control header is one of those. It identifies capabilities, like the second option, content equals ESI 1.0. So it allows you to do more than caching. It can act on behalf of the origin system, and Varnish can do that. So surrogate control content ESI 1.0 is announcing that Varnish can process output and parse ESI tags. We'll show that in a couple of minutes. Surrogate control maxh 3,600 per 600 is a pretty strange construction, but it says that Varnish can cache the output for an hour and add 600 seconds of stale while revalidate. So all these headers are supported. And then the bottom one is vary. It is a response header that is used to create cache variations, because normally an item in cache is identified by the URL. But let's say you use the accept language header to do language detection and present multilingual content. Well, in that case, you will need to create a variation per language. And that is exactly what the vary header does. So all of this is good, and it will work, or it sure seems like it would work in production, but there's one thing that will always get in the way. And that, ladies and gentlemen, unfortunately, is state. And with state, I mean user-specific data. And with user-specific data, I mean authentication headers and cookies. And in most cases, let me tell you, it will be cookies. And as caching theory specifies, when content is for your eyes only, and that's usually the case, you cannot cache it. So here's the conclusion. Varnish has an extremely cautious standard behavior because it's worse to cache data that you're not supposed to cache than not to cache anything. So Varnish, whenever it sees a cookie, it will not cache. So your gut reaction would be, so nearly all websites in the world have cookies. So does that mean that Varnish doesn't work on the majority of the websites? No. Again, this is just standard behavior, and you can extend it. Thanks to the Varnish configuration language, or VCL as we call it, you are able to extend the standard behavior. Now, the Varnish configuration language is a DSL, a domain-specific language. And that means a language that is specifically tailored around Varnish. There's no other domain of application. And I'll start off with showing you a little bit of code and explaining what is going on. So Varnish is not a top-down programming language. You don't use it to program the entire behavior. As I mentioned, the behavior is already there. You can hook into specific items, specific stages of the so-called finite state machine. So there's a flow, you extend certain behaviors, certain patterns. So what we're doing here is extending the sub VCL receive. So by putting logic in subroutines, you can extend that behavior. The behavior we're extending right here is whatever is received by the client. So VCL rec v is we're receiving an HTTP request. What we're doing here is inspecting whether or not there's a cookie. So if rec.http.cookie exists, it means a cookie was sent by the client. What we're trying to do here is, and I admit this is very ugly regular expression magic, but there's ways around this. I just wanted to show how this is done in the wild, because actually this very snippet comes from Drupal. Drupal uses this very logic. And what it does is it removes every single cookie besides the ones that are matched by the regular expression you see marked in red. So Drupal creates session cookies called ses, and then A to Z or 0 to 9, so alphanumerical content, or SS, or you can also drop a no cache cookie. So we keep those. All the rest gets stripped off. And if it turns out after the substitution that we're left with an empty cookie or just an empty string with white space characters, we strip off the cookie. As soon as we strip off the cookie, default behavior kicks in and the content is cacheable. If it turns out the cookie is still filled up, it means we created the session. It means we're logged in, so we don't cache. So that's a way of approaching it. Another way of approaching it is very interesting. So you can also use cookies to your advantage. Instead of saying, well, if there's cookies, we don't cache, and if not, we can cache, we can leverage cookies. So imagine that you have a multilingual website, and on the homepage, you present a splash page where you can pick your language. And as soon as you pick your language, language is stored in what we call a language cookie. That could contain EN or FR or DE or ES, depending on where you're at in the world. So what this does is it caches the cookie, because as soon as the language is selected, the actual content in the requested language is presented. So in this case, we remove every single cookie, but we keep the language cookie. And if it turns out that there is no more cookie data left, we strip off the cookie. But either way, we do an explicit return hash. And this means even though we're not supposed to cache this, we are going to cache this. And then the kicker is, and this is what makes it a lot of fun, is we're extending sub VCL hash. So that is the way we are identifying objects in cache. Usually this would be done based on the URL, but you know the danger of this. It's first come, first served. So when a French-speaking person would be the first and would result in storing this object in cache, when an English-speaking person would come, he or she would see French content. So that's not the goal. So what we're doing here is creating a cache variation based on the language value. So we're extending the cache hash and extracting the language value. And there you have it. This is a way to cache multilingual content. So that's a lot of fun. This is the easier way of doing this. So if you're on a recent version of Varnish, you might leverage a cookie module that just allows you to parse it, keep the language, reset the cookie or rewrite the cookie back to the header, and then just get the language cookie. It's a lot simpler. I just wanted to show this is less popular, but I do want to advocate this as a Varnish evangelist. This makes your life a lot simpler. Now, imagine the following setup. This is as typical as it gets. These are my designer skills, ladies and gentlemen. You have your typical header, a footer, a navigation, and a main page. And everything is cacheable besides that header because it contains user information. Maybe it's a shopping cart where it says how many items in the cart you have, or maybe it's just login information. Hello, Thijs. Hello, Mark. Hello, Sarah. That kind of value. So how do we tackle this? How do we make sure this is cached? Because out of the box, this is presented as a single HTTP response. A cookie is presented, and the largest common denominator says, please don't cache this. So that's a bit of a problem. Now, I know you're clever people. You know what I'm going to say next. There's ways to tackle this, and that is by using placeholder technology. And you'll probably see this coming miles away. But instead of presenting this as a single HTTP response, there is trickery to be done to load the header as a separate HTTP request. Well, without any further ado, I'm going to present the most common way of doing this through AJAX. AJAX, asynchronous JavaScript over HTTP or whatever it's called. It is a very common way of doing things. You just load the header via an AJAX call. The main page is cacheable. The AJAX call isn't. And there's some advantages to it. It is client-side, so it's written in JavaScript. So it's very simple. It's common knowledge. People pretty much know, or web developers pretty much know how to write an AJAX call. And there's frameworks for it. And you can do parallel processing. And there's this sense of graceful degradation, as we call it. If your AJAX call would fail, well, you can choose, instead of crashing the entire page and throwing a big error, you can choose not to show that widget, and the rest will continue. But there's also some downsides. The fact that it is client-side is also the main disadvantage, because now you're shoving that responsibility to the end user. The browser needs to deal with it, and how it deals with it is sending extra round trips to the server. And on fast internet connections, that is no problem. But if you're on a pretty crappy 3G connection somewhere in the middle of nowhere, then that will be slow, and every extra round trip is something we want to avoid. So keep that in mind when trying to splash AJAX around. There is another way. It's called Edge Side Includes, or ESI. Now, the old timers here in the call, in the presentation, will be familiar probably with server side includes from back in the day. Server-side include was just a placeholder, XHTML style. It's like an HTML tag. You put it in your content and your web server will handle it and will load it. Well, server-side includes and edge-side includes actually quite similar. With the difference is that edge-side includes, as the name implies, are executed on the edge, which means at the outer tier of your web platform, so basically by Varnish. This is what an ESI tag looks like. It's basically a placeholder that says we're including ESI based on a source attribute. So what this means is that wherever you drop this in your application and you send it to Varnish, and Varnish knows that it needs to parse it, it will automatically load the header endpoint and just parse the content wherever that placeholder is. And that is pretty cool. And that means that this header will be loaded within Varnish as a separate sub request. However, it will be presented as a single HTTP response to the client from Varnish's perspective. So let's recap ESI. It is placeholder technology. It is parsed by Varnish, and it allows you to create a composition of blocks where each block is represented by a separate URL that is loaded within ESI, and that has state per block or TTL per block. So you can choose not to cache whatever's in the ESI tag because it's probably stateful, it uses cookies, and all the rest will be cacheable, and it's done in a single round trip, and Varnish takes care of it. Pretty neat. And this is how I would advise you to implement it. There's various ways out there in the wild, and I think there's a lot of CMSs and frameworks that already support it, but this is my preferred way. You announce it through surrogate capability header. So when you send the fetch request to the backend to fetch content, you can already say from Varnish's perspective, hey, dear application, I support ESI. And whenever the origin application sees this, it could opt to say, all right, if you support this, I'm going to throw in an ESI placeholder. It's up to you to parse it. And the backend application will respond with a surrogate control header. And when it contains ESI, Varnish spots this. It removes that surrogate control header because, of course, the client has no business seeing that. And then here's the magic. We're enabling due ESI, and that gets processed. So that is pretty nice and very flexible. And it leaves the control at the application level. It's all about developer empowerment in my mind. Advantages and disadvantages. The advantages, it is server side. So that means you're not bothering the end user with it. There's no extra round trips. Another advantage is this is not something we invented. It's actually a W3C standard. It was invented by Akamai, the very popular CDN provider, and it's implemented all over the place. So it's processed server side, but not on the origin server, but on the edge. So you're taking away a lot of the load from the server. And in the end, and that's why we do it, it's generally faster. There are problems, and you can see that in column number 2. It is sequential. So that means it's one after the other. If you have multiple ESI requests in a single response, if there's a slow one, it will block the line. Of course, if you take the enterprise version, we have a solution to do it in parallel. There's no graceful degradation, or not without doing any trickery. So if one of these sub requests fails, all fails, and your entire website blows up. So that's a bit of a problem. There's a limited implementation in Varnish. Varnish supports the basic, but not the full spec. And all in all, I think it's not as common as Ajax. Some frameworks implement it, and I commend them for that. But a lot of people just stick with Ajax. But if you can, and if you have the capabilities in your application to support ESI, please do so. So we need to, because we are at a sort of crossroads here in the presentation, I want to recap the first part of the presentation. What we have learned is to remove unwanted cookies, leverage cookies for cache variations, and use placeholders to load stateful content. And all of this is done to increase the hit rate, to make sure that the origin application doesn't get a whole lot of requests. And we've done a decent job. And even if we have a 95% cache hit rate, you're still stuck with that non-cacheable stuff. Those non-cacheable routes, even though they're minimal, will still be a target for heavy load and heavy latency on specific applications. And we need to address those. And in part 2 of the presentation, which has started now, we're going to tackle that. The first step is making a statement again and saying, I'm glad to announce that Varnish is more than just a cache. It's not just a take it or leave it cache. And with that, I mean, the decisions we've made so far is you can either cache or not cache. And if it's stateful content, we decide not to cache, and otherwise we cache. So it's a binary thing. It's true or false. We need to get beyond that. And we can do that because Varnish is more than a cache. It is also in HTTP logic box. And it allows you to make decisions on the edge. And that is exactly what we're going to do in part 2. An easy way of doing this, and I must admit, I'm just trying to make a point here, this is very idiotic. So you can return synthetic HTTP. So when you receive a request, instead of getting it from the cache or fetching it from the backend, you can just return a 200 with synthetic output, it says. And then the client will get synthetic output as a response. But it will be parsed in a template, and this is the template. So it will return some base HTML with some things that might not make sense at first. But this is also leveraged when an error occurs. So when the origin is not available and Varnish tries to connect to it, it will also throw an error. An error like this, error 503 backend fetch failed. This is happening automatically. And as a matter of fact, you might have recognized this. This was the running joke yesterday. You might see this one. This is the end result. And let me tell you, a lot of people saw that one yesterday. So yesterday, a very popular Varnish-based CDN, and I will not name or shame them. I will have the courtesy to do that. They were down, and I think half the internet was down yesterday and saw errors like this. A lot of people made the instinctive reaction of saying, hey, this is a problem with Varnish. But it wasn't really. It was just synthetic output being generated by that very popular CDN provider because they had an issue in their CDN. So that's that. And we can leverage all of this. We can leverage synthetic output to our advantage. And this is where it gets really interesting. Now imagine this. Imagine our website composition. You remember that we have a header, and in that header, we want to load the username. And the username is stored in a RESTful endpoint. It's called /API/session. And the output is based on a session ID cookie. So my session begins with 7ER and what have you. And the result is a JSON object with a username property, and the value is Thijs. Now this is stateful. So based on whatever we've seen so far, it's not cacheable. But I'm going to show you how this output can be generated by Varnish. And the trick is that Varnish has the capabilities of interacting with the session storage. And for all intents and purposes, let's assume that your web farm uses a distributed session storage, Redis in this case. It uses Redis to store all the sessions. Cool thing is Varnish can connect to Redis. So let me throw in an example for you. So what we're doing is importing a bunch of modules in the beginning, then defining the backend where we're going to connect to. And we're going to connect to the backend. You'll see that on the following slide for all the requests except the ones that we're trying to intercept. When we initialize the Varnish setup, we're going to open up a connection to Redis. Now, Redis is hosted on hostname Redis. This comes directly from my Docker setup on the conventional port 6379. So we have a Redis client available in the Redis_client object, ready to rock and roll. When we receive a request from the origin, we're intercepting the one for /API/session. So if that URL equals API session, we're going to extract the session ID, so the session cookie, and get the value and store that in a header called rec HTTP session ID. And then we're going to explicitly cache. So even though there's a cookie, we really want to cache this. In the next step, we're going to make sure there is a cache variation for the session ID. So that means even though you're accessing API session, there will be a version for every single session ID. It might sound a bit crazy, but bear with me. When it turns out the content is not stored in cache, we need to fetch the data from the origin. Now, usually that would be our default backend. Let me go to the previous slide. You see it. Backend default is backend.example.com. So usually we would get the content there. But in this case, we're going to intercept it, and we're going to do a call to Redis. You can see that below the if statement in VCL backend fetch. We're going to send an hget command to Redis, which means get a property from a hash. A hash is a data structure. It looks a bit like a struct in C. And then we push the session ID that we extracted earlier, and that contains the exact session ID that was set in the cookie, and that is also the identifier of the session in Redis. And then the value we want to get is the username. So we push the username field as a desired field we want to get. We execute this, and then we evaluate the result. If the reply is nil, it means it wasn't found, or it could be an error. In that case, and this is where some more magic happens, we're going to set a backend, and we're going to use a synthetic backend. So instead of fetching it from the real backend, we're going to create a fake backend that uses a string value. And the string value is an empty object. So you're based with an empty JSON object. In other cases, when we did get a result, we're going to do, again, that synth backend from string, and we're going to get the Redis reply. So whatever username was gotten, we're going to format it using sprintf style formatting, and we're going to artificially create the username object within the JSON object, and then add the value to it. And it will be stored in cache. If it's not the API/session endpoint, we'll just send it to the backend. So this way, we're really intercepting that, creating the content ourselves and storing it in cache. And then when it's time to return the response, we intercept it as well, assign the right content type, turn it into application JSON. And here's the fun part. We decide to cache it for the next 3 hours. So for the next 3 hours, as long as it exists, you will get it from cache, and it will be lightning fast. And with lightning fast, I mean, benchmarks have shown that Varnish can process, in lab circumstances, of course, more than 800,000 requests a second, with a throughput rate of 200 gigabits per second over TLS, and when items are stored in cache, sub-millisecond response time. So you can really make it fast. And when the cache expires, or when you explicitly invalidate the session, well, then you connect to Redis again. And you probably know this as well, Redis is super fast. So that is pretty exciting. That is pretty cool. So you end up with username Thijs, in my case, based on my session ID, and your origin system that is supposed to handle this wasn't even touched. Only Redis was accessed. And for the rest, it was stored in cache. Pretty damn cool. So what do we do with it? What do you do with that API/session endpoint? Well, you can use it as an AJAX call to load the username in the header, or you can choose to load it via ESI and parse it in your local JavaScript, which is also a possibility. Or, and here's where I'm going to introduce something else, we can use EDGESTASH. EDGESTASH is a conjunction of edge and stash refers to mustache, the well-known templating language from JavaScript, and edge means we're doing it on the edge. So long story short, this is a module, a Varnish module, to do mustache processing on the edge. And mustache, it's very popular. You probably recognize this here. It uses double curly braces as placeholders, and whatever value is in there is a variable that needs substitution. So in this case, that would be an EDGESTASH variable. So what the goal would be is, on the right-hand side, we see the output from our API session endpoint that contains the username case. What you can do next is, in your application, you can just throw out a username handlebar, unparsed. And EDGESTASH will be able to take that and make this otherwise uncacheable thing cacheable by storing the template rather than the value, and then doing the parsing at delivery time, connecting to the API session endpoint and parsing it all together and turning it into that nice diff with Thijs. Here's some code. There's always code, of course. Here's the code. So we're importing EDGESTASH, and rather than doing a sort of full-blown example, there's just not enough screen real estate, unfortunately. So what we're doing here is, I'm just going to show you the EDGESTASH part. Whatever we've done with API session, you can just merge that in there later on. So we're just assuming that API session works. So when we're trying to connect to the backend, because the content is not stored in cache, and we notice that whatever is trying to be accessed is API session, we're going to make it even faster by indexing the output. So the EDGESTASH module can index all the properties coming back from the JSON object and prepare them for later parsing. In this case, if the request URL, or the backend request URL rather, is the home page, well, there is where we want to do some parsing. And then we trigger EDGESTASH.parse response. It will look for all the handlebars. And at delivery time, which you see in sub VCL deliver, we're going to inject the values. So if we notice that whatever we're trying to deliver is the home page, and we already parsed some EDGESTASH, and we notice that there were EDGESTASH placeholders to be replaced, we're going to call the EDGESTASH at JSON URL endpoint and just inject the endpoint that we want. And this is basically how it's done, by calling EDGESTASH.execute. At delivery time, it will call the value and will parse it. So it's not at cache time. So whatever is stored in cache is just the template. Every time you deliver a content, the content can be personalized. This is how you make uncacheable data cacheable. And then the solution is, instead of using ESI or using AJAX, you can actually turn the header into an EDGESTASH placeholder, and in your VCL content, you can load the API session endpoint. But I guess, ladies and gentlemen, you need a little bit more flexibility here, because this was very hard coded on the homepage. I'm going to do this quickly, not focus on this too much. Like, we can use the surrogate control header again and make surrogate capabilities on EDGESTASH. But when the origin replies with surrogate control and it uses EDGESTASH, as the name of the key and it has EDGESTASH in it, Varnish can look at that and say, okay, well, this application is probably sending EDGESTASH output. We need to parse it. But where's the stateful endpoint? Well, in that case, you can use a link header and give it a rel EDGESTASH, and then Varnish can interpret that endpoint and load it. Here's VCL. Again, let's not focus on it too much. Look at the blue parts. So what we're trying to do is using standard collect to collect the link header. With collect, I mean you can have multiple link headers. You can use multiple link headers like this. You can have API session, API card, whatever. This collapses it into a single header and uses commas. And then it's a matter of parsing this into a very long, very complicated regular expression. And the comma-separated list of EDGESTASH JSON URLs is there. And you've seen most of it, but at delivery time, here's the fun part. You can do @JSON URL CSV, inject those comma-separated URLs. Varnish will load them, parse them, and that way you have full flexibility. But then you might say, well, this is all fine and dandy, but I don't really want to touch my code. Like, I'm dealing with a legacy application and I can't really inject those EDGESTASH patterns in there. And then I say, fine, no worries. There is a way of doing this automatically. So again, this is an isolated example where we use a module called xBody. And xBody will do a find and replace on the body when it stores it in cache. So in this case, we're looking at a diff that probably has a value and that has an ID username. So we know in there, there's the username. So what we do is we look for it, and then using regular expression substitutions, we replace those values and inject the handlebar. So this might look complicated, but this is what happens. So your application sends this diff, and it has stateful content in their taste. And what we do is we just replace it with username and handle the rest later on. So that is also a flexible way of making it non-intrusive. You can make this happen without touching the code. So we're almost reaching the end here of the presentation. I'll leave plenty of time for Q&A. Whatever you've seen here, most of it is available in Varnish Cache. And I have to be honest, not all of it is Varnish Cache. I've shown some Varnish Enterprise thingies as well, such as EDGESTASH, such as synthetic backends and xBody. But the Redis module and basic synthetic output can be done using the open source version. However, if you want to try this enterprise thing, and I want to add a really big disclaimer, I'm not a salesperson, I'm an evangelist. I'm not trying to sell you anything. I'm trying to make it easier for you to play with technology. We have official Varnish Enterprise images on AWS, on Azure, and on Google Cloud, where you can play with this technology. And there's free trial, and I even advocated, and I've succeeded, to have developer editions available. Currently on AWS, but it will find its way to the other platforms as well. So it's super cheap for developers to play around with. However, if you have another cloud platform, you want to play around on the cloud with Varnish Cache, the open source version, we have free versions available on DigitalOcean and Alibaba. So in the end, I want to make a big statement, is that Varnish was known for website acceleration, but all this technology and all these capabilities you've seen at large scale, this is used to build content delivery networks. So Varnish basically is CDN software. And I want you to remember that, because there's plenty of private CDNs these days being built using Varnish. And my advice to you is, when the going gets tough and when stateful content is interfering with your operations, make more decisions on the edge. You've seen how it goes, and there's plenty of other implementations. If you get my book, which is available for free at www.varnish-software.com, you'll find a link there. You'll find plenty more examples of making decisions on the edge. And here's the kicker, here's the bonus. I still have 1 minute. Here's some other more cool personalized caching things you can do. Like, you can do device detection if you want to. Are we on a mobile device? Yes or no? By using a device atlas module. And there's a really rich ecosystem of modules available. Here's where you can do geolocation. You can target specific users. You can block specific users. It uses the MaxMind database. You load it, and then you say, if the country is not Germany and not Belgium, well, then you're not allowed to see the content. So this is geo-blocking. You can also do geo-fencing, geo-targeting, whatever. So this also allows you to make decisions on the edge. And here's a final one. Here's where we use the link header to prefetch content. So if you use a link header and have a rel, a specific rel in it, rel prefetch, rel next, we can interpret that and already load the content in cache. So for example, you want to load some CSS and JavaScript while loading the main page, we can do that for you and make sure it is in cache. So that is it, ladies and gentlemen. And we have 2 more seconds before the Q&A starts. So now is your time. If you're too shy or you can't figure out a question right now, don't forget I'm available on Twitter as well. So get me there if you want to do it more on a one-to-one basis. If not, if you want to throw it in here, if you're anxious, I want to do it right now. Now is the time. I'll wait a minute here. And in the meanwhile, while you are typing up potential questions, I would like to thank you for being here. I had a lot of fun. I couldn't see you, of course, but there was a little bit of interaction in the chat, which is always fun, of course. And with that being said, I thank you. And I hope at some point I will be invited by the organization again to fly to Lithuania, fly to Vilnius, and do it all over again in real life. And I hope to see you there. Cheers. We have a question, ladies and gentlemen. Are there cache busting techniques in Varnish? I'm glad you asked that, Zigimantas, so I hope I pronounced your name right. There are definitely cache busting mechanisms, and Varnish is famed for its cache busting mechanisms. With cache busting, we mean not waiting before the content expires. With that, we mean we actively purge content. There is a very rich suite of tools you can use for that. You can use purging techniques where you, instead of doing an HTTP GET, you do an HTTP purge call. So this is a non-existing request method, but you can use it. It's pretty standard. WordPress uses it. I think Magento uses it as well. And then Varnish can actively remove that object from cache. We also have an entire ban syntax, which is a syntax you can use for pattern matching. So instead of removing one item from the cache, you can remove like hundreds or thousands or millions of objects at the same time, as long as it matches the pattern. And then there's also secondary key mechanisms where you tag content, and in the end, it's just a matter of invalidating the tags. So there's a very rich ecosystem of that. You will find that on varnishcache.org. I'm currently building a developer portal for Varnish software where all these types of questions will be answered. And of course, if you get my book, available at varnish-software.com, I have an entire chapter on cache busting. If you have the book already, it's chapter 6. Thank you for asking. So we have 2 more minutes. Now is the time to ask other questions. If not, I will end the session gratefully, and thank you for being here. So I'll wait 1 more minute. Thirty seconds left. All right, that's it. Thank you for checking me out. Enjoy the conference. Thank you to the organizers for inviting me. I had a good time. See you on the next session, on the next presentation, and on the next conference. Thank you very much.